Okay, hello guys, this is Kim 301 and we have a question here to answer. The question is, a ray of visible light has a wavelength of 480 nanometer, and the question is, what is the frequency in hertz? B, wave number in centimeter inverse or reciprocal centimeter. And we have a relationship that we can actually use to make this calculation, and let me take you to the part of it now. Okay, here we go. Part 1. This is the relationship. Your speed of light is equal to the frequency multiplied by the wavelength, where c is speed of light, v is frequency, and lambda wavelength. And the speed of light is constant 3.0 times 10 raised to the power of 8 meter per second. And now, because we are given our wave length in the question as 480 nanometer, the units of wavelength and that of meter of our speed of light, there is a disparity because we have a nanometer and we have a meter, so we have to convert one to the other. And since this is a constant, let's go with conversion of this, which can be varied. Now, here's a conversion factor. 1 nanometer is equal to 10 raised to the power of negative 9 meter. And then we can make a table, conversion table. 480 nanometer will be equivalent to 1 nanometer will give you 10 raised to the power of negative 9 meter. Now, you write it in such a way that the units up here can be able to cancel the units down, or the unit down can be able to cancel the units up, because that is what you want to actually do away with. You should know this from your basics. Now, this and this will cancel, and you have 480 times 10 raised to the power of negative 9 meter, and you're going to have the answer as 0.000048 meter, which in standard form is approximately 4.8 times 10 raised to the power of negative 7 meter. Now you're good to go, because the units of wavelength are tallying somehow with the units of speed of light, which is a constant. And now we can use that relationship which we spoke about here, down here now. Now we can just make, from here, you're just making your frequency as your subject to the formula, because that is what you're interested in looking for. So if you divide both sides by the wavelength here, then you can have your speed of light, your frequency equals to speed of light divided by wavelength, and that is what you have here. Your frequency now v, which is equal to speed of light c divided by wavelength lambda, and you can just substitute the values which you already have. Frequency will now be equal to 3.0 times 10 raised to the power of 8 meter per second, which is a speed of light as constant, divided by 4.8 times 10 raised to the power of negative 7 meter, which you have converted 480 nanometer into meter. And once you divide this by this, meter and meter will cancel, and you have per second left there as a unit. And you have your answer as 6.25 times 10 raised to the power of 14 per second. However, you've been asked in the question that you should be able to calculate what is the frequency in hertz and not in what per second. And because of that, we use a conversion factor again, 1 per second to hertz. And the unit is that you have 1 per second is giving you 1 hertz. So invariably, within that calculation, you know that the same thing will give you the same value in hertz. So you have 6.25 times 10 raised to the power of 14 per second will now be equivalent to 1 per second will give you 1 hertz. And this will cancel, and at the same time you have the same answer, 6.25 times 10 raised to the power of 14 hertz. And that's your answer in question what A, what is frequency in hertz. Now for the second part, you're asked to calculate the wavelength in reciprocal centimeter, and the wavelength we know is that it's the inverse of the wavelength, and we were given the wavelength for the question as 418 nanometer, but we've already converted that to 4.8 times 10 raised to the power of negative 7 meter, because the relationship is going to be in reciprocal centimeter, and we know that we have a unit of conversion from centimeter to a conversion factor from centimeter to meter. 100 centimeter is equal to 1 meter, and you know that very well. So now we can just put that here into use. Now our wave number is equal to 1. That is the inverse of that wave number, 4.8 times 10 raised to the power of negative 7, and you're going to have 2.08 times 10 raised to the power of 6 meter what inverse, because you've divided this by 1 already, and this is down, and this is going to be appearing as a meter inverse. So you can take back to the conversion factor of meter inverse to centimeter inverse. Now same unit which I told you conversion factor is 1 meter inverse is going to give you 100 centimeter what inverse. then you're going to have 2.08 times 10 raised to the power of 6 meter inverse. Now, this and this will cancel, and this will leave with 2.08 times 10 raised to the power of 6 multiplied by 100 centimeter inverse, and this will give you your wave number to be 2.08 times 10 raised to the power of 8 centimeter inverse or centimeter reciprocal as your answer in B as the wave number. Thank you. I am Cyprian Ahura, currently studying industrial chemistry at Benue State University in Nigeria. Thank you for watching, and stay tuned for more. If you have questions or you have corrections or you have observations, kindly put them down in the comment box for me to take note.